I'll just explain myself. Myself and Ned work for a small independent environmental consulting company, but I'm contracted to MFE for half my time approximately, and I work in the Water Directorate in the evidence team, and I'm appearing here today in that capacity. My talk's quite high level. I'm going to gloss over quite a bit of detail, and my colleagues who follow me will fill in quite a few of the gaps in my talk. The outline, what I'm going to briefly talk about is LORF's recommendations and how they influence the NPS. In particular, the idea of numeric objectives, national bottom lines and limits. I'm going to talk about the role of attributes and gluing all of those things together and how they make the system work. And I'm also going to then, at the end of my talk, talk some specific technical stuff around how attributes deal with the inevitable environmental variation that occurs. So the way what I'm going to do is I'm going to briefly describe how the NPS directs regional councils, first of all, to think about some questions. And it asks regional councils to think about questions in increasing levels of detail. And the answers to those questions are eventually going to become provisions in regional plans. And so I'm going to run through these questions and show how, first of all, LORF's recommendations influenced the NPS and how the NPS is responding to these questions. The first point, sorry, I'll go back one. The first point is the big question that we need to answer is what are the benefits we want to get from the environment? And ultimately those are reflected as values. And the Land and Water Forum recognise that there's a wide range of values, and among those values there are some very specific values which the NPS has defined as compulsory values. So in a nutshell, they're ecosystem health and human health for recreation, and these are values that must be considered for all freshwater bodies. Having thought about those values, the next question that's asked is what is our aspirations for those values? How do we want to maintain them, and what are objectives for those? And they can be, the response to those questions is often what we would call a narrative objective. This is a relatively high level statement, and it's typified by the notion of maintaining life supporting capacity. It's a very high level goal, and the important recognition that the LORF process came to was that that's a very broad and not sufficiently specific response to that question to enable us to set justifiable limits. So therefore, at the next step, we need to refine what we mean in those from that narrative objective, and we need to ask ourselves, what are the specific factors that we're thinking about here? And that finds its way into the NPS as attributes. So attributes are specific components of the environment which reflect, which need to be considered in order to achieve those narrative objectives. And the example that I'm going to use today is periphyton. And so I'm going to leap out of this conversation now just to clarify what I mean by periphyton, and I'll keep coming back to that example. So periphyton is the green slimy stuff we see on the bottom of rivers. It's essentially algae. It's the basis for the food chain and expresses the trophic state of the river that it's growing in. This is essentially the primary production. So it's obviously needed to sustain the ecology of the system, but too much impacts on ecosystem health. So therefore, we need to try to manage the abundance of periphyton within sustainable levels. So the pictures here show different types of periphyton, so it's obviously very complicated when you get down to the details, but at this stage we're just talking about green slime. And fundamentally, the resource use which most impacts the abundance of periphyton is the result of nutrient discharges. So when I talk about nutrients in this talk, I'm simply talking about nitrogen and phosphorus, and the concentrations of those and the loads of those. They're strongly related to our land use, and some of the details, there's a lot of detail obviously underneath that, and that'll be covered in my colleague's talk. In particular, Scott's going to talk about that in some detail. The important point though is that we need to maintain periphyton at a level of abundance which is acceptable, and we want to avoid this kind of situation. This is a bloom of a filamentous algae in the Rangitikei River. So going back to our questions, having defined an attribute, so this is a specific environmental factor that we need to concern ourselves with, we need to have measures and thresholds set for those attributes, and those measures and thresholds become the basis for numeric objectives. So these are objectives now which are much more specific and have numbers attached. And so for our example of periphyton, the way we measure periphyton is through chlorophyll. Now chlorophyll, most of you will know, is the green colouring in plants. It's the basis of photosynthesis, and it can be measured in rivers as the amount of chlorophyll per unit area of the bed, and that's a measure of the abundance of periphyton. And so different states of periphyton with respect to periphyton are defined in the NPS as bands. And obviously we've got low levels of biomass representing high levels of environmental quality, are A band, down to the D band, which is, defines the environmental bottom line, the national bottom line. So then back to our questions. Having defined a numeric objective in terms of chlorophyll and a concentration of chlorophyll, the next question is, how do we achieve those objectives? And the insight that Lorf had was that really having defined an objective, we need to think about how do we limit resource use so that that objective is met. And the reason for that is most of our resource use impacts in a cumulative way. So we need to limit the amount of resource use in order to achieve that objective. So in the context of something like chlorophyll and its obvious association with nutrients, the limits can be expressed as catchment nutrient loads, for example. And so then the final question is, having defined the limits, how do we live within the limits? And so this is captured now with the response to that is actions. So those actions can be things like nutrient allocations, mitigations, etc., which enable us to adhere to the limits that have been set. Okay, so that's a very rough outline of how the NPS works. The second part of my talk is around some of the detail of how attributes deal with the inevitable situation that an attribute is expressing an environmental state, and environmental states vary in both space and time, and how do we deal with that? So to do that, I'm going to talk once again about periphyton, and I'm going to use a very simple cartoon, if you like, which summarises the large-scale processes which are controlling periphyton abundance. I'm glossing over a lot of the detail here. For example, I'm going to express things as linear relationships when in fact often they aren't, and I'm not going to talk about all of the factors which control periphyton abundance. But in this graph, periphyton abundance is the vertical axis, time is the horizontal axis, and so starting from time zero, periphyton abundance is controlled by the growth rate. So the growth rate is determined by a number of factors. We've already mentioned nutrient concentrations, but there are other factors. So for example, light and temperature are obviously very important, and everyone who's grown a lawn understands that. Now, so the abundance that's achieved is determined by the growth period. So if we have a low rate of growth or a high rate of growth, the abundance that we achieve depends on how long we have to grow. And in a river, that's a period of stable flows that allows the growth to occur and the biomass to accumulate, and it's terminated by a fresh. now. So people often refer to these as floods or flushing flows. I'm going to refer to as a fresh today. And a fresh, of course, is a flow of sufficient magnitude that it cleans the periphyton from the river, flushes it downstream, and the process starts again. So the growth period is essentially the time between freshes, or at least in this simple diagram. So therefore, over the course of a typical year, periphyton grows for a growing period. That period's terminated by a fresh, and that pattern reproduces itself. And the time interval between freshes is variable, and therefore the growth rate is variable. And therefore, on any particular occasion, there's a variable amount of biomass in the river. Now, under the NPS, the requirement is to monitor this on a monthly basis. So if we go out every month and we measure the biomass, we end up with 12 samples of biomass. And obviously, what we need to do is compare those to a threshold. So we talked about the A, B, C, D bands. Those are the thresholds. We compare our samples with our threshold, and in this situation, we're never exceeding the threshold. So we're obviously meeting our objectives in this particular situation. Now, the problem with this is that the environment's variable. In particular, the frequency of freshes is variable, and this means the duration of growth periods is variable. And so what that means is that, in particular in dry years where there might be a drought, there might be very long growth periods, and that means from time to time we may be able to see an exceedance of any given threshold. Now the point though is that ecosystems are resilient, and occasional exceedances of these thresholds are tolerable. So the important point is that as well as setting a threshold, we need to define the allowable exceedance frequency. So just to come back to this point about environmental variability, what I'm showing you here is annual hydrographs. So that's the distribution of flows through the year in the Waia River in Canterbury. And what you can see is that in the top panel there's a typical year where the year is punctuated by a series of freshes. And in the middle panel there's a wetter year where there are larger freshes and they're more frequent. So obviously the growth periods are shorter in that year, and we would expect therefore that there would be lower biomass observed in that year in general. But then of course in the bottom panel we've got a dry year, and in this year we have long periods of recession. We have an absence of very frequent freshes, and we have some quite long growing periods. So in this particular year, we may end up having an exceedance of that threshold. And so, as I said before, this particular cartoon, we're showing one exceedance, and that's tolerable and allowed under the provisions of the NPS. Now, the point though is that if we were to increase the nutrient supply in the river, we would increase the growth rate, and therefore in the same period we would have achieved higher biomass. And so in that instance we may have, for example, exceeded the threshold on 4 occasions. And in that circumstance we're not meeting our objectives. So how this is handled under the periphyton attribute is, first of all, we need a threshold, and secondly, we need an exceedance criteria. And for periphyton, this exceedance criteria is an average of 1 exceedance per year. But this is taken over the long term, so that's if we're using monthly samples, that's an exceedance criteria of 8%. And what this means is that in some years you might have more than 1 exceedance, provided that in other years there are fewer than 1 exceedance. So that's dealing with temporal variation. The other aspect that we need to handle is spatial variation. So we've seen from what preceded is that the frequency of freshes is very important in determining biomass. The important point though is that the average frequency of freshes, and therefore the average duration of the growing period, is spatially variable nationally. So this map here of New Zealand shows the frequency of freshes, essentially. There's a floods that exceed 3 times the median, which is well correlated with periphyton abundance. And what this shows is that on the western side of both islands, we can have 30 or more events per year which could be considered freshers and which will clean the system on average. On the east side though, we have far fewer events. We have sometimes less than 10 events per year. And obviously even within regions there can be large variation in these numbers. So this means that the variation in growing periods there's a strong variation across the country, and that means that locations which have frequent floods have shorter growing periods and therefore on average produce lower biomass for the same nutrient concentration. So what that means then is that nutrient criteria needs to be spatially variable. So if we're setting nutrient criteria to achieve a periphyton biomass outcome, we need spatial variation in those nutrient criteria. And the number one thing we need to recognise, of course, is the frequency of freshers, but there are other details as well. I've already mentioned light and temperature. And these complications mean that the setting of the nutrient criteria needs to be defined at the local level. And really we're talking down at the catchment scale. How this is done is using obviously scientific relationships. The first decision is what is the objective. So those are those two 45-degree lines, whether we're going for 200 milligrams or 150, 120 milligrams. And the relationship shows the relationship between the frequency of freshers and the required nutrient concentration to achieve that. Applying those sorts of relationships to a spatially variable environment produces a spatially variable outcome for nutrient criteria. And this example here is drawn from the ECAN's Natural Resources Regional Plan. And what they've done is they've defined 9 different types of rivers to which different objectives apply, but also to which different nutrient criteria apply. And these are really recognising that within these different types we have different, amongst other things, frequency of freshers. Okay, so in conclusion then, regional councils need to give effect to the NPS. And so the NPS provides national direction, but through this sequence of increasingly detailed questions, the implementation is devolved down to smaller scales. And ultimately, what LORF recognised is that much of the detail needs to be decided at the catchment scale. The important thing which the NPS brought was the notion of attributes. Attributes link ultimately the values right through to numeric objectives, limits, and the actions that are required to ensure those values are sustained. And so they're really glue in the process. They support the definition of numeric objectives and limits, and that was an important insight that LORF came to, that we really need numeric objectives to make this all work. And as I've hopefully demonstrated to you, attributes account for environmental variability. These ideas were foreshadowed in LORF's 3 reports, and they strongly influenced the details of the NPS, and in particular the amendment in 2014. Obviously the devil's in the detail. I've glossed over an awful lot of tricky stuff. MFE continues to work on guidance, development of new attributes, and assisting councils with implementation. So thank you.